So vitamin C, as many people know that have read Linus Pauling's works on vitamin C, or have read Dirk Pearson and Sandy Shaw's works, or have read Levy's works, or any of these people's works, vitamin C is a very versatile nutrient, and it's more similar to a hormone. And the thing here that you have to remember, this is vitamin C being given to male rats. Now, rats make their own vitamin C. So this is showing that vitamin C is even beneficial to animals that already make this hormonally. So hyperglycemia can impair the male reproductive system, high sugar. So that's another reason you shouldn't be spiking your sugar and keeping your sugar high. Okay, so studies have shown that vitamin C has some good effects on the male reproductive system, and therefore vitamin C treatment could attenuate dysfunctions in this system. Okay, let's go to the conclusions. We conclude that vitamin C partially attenuated some male reproductive system dysfunctions in hyperglycemic rats. Okay? So, male sexual dysfunctions are frequently associated with hyperglycemia in experimental rats and in men. It is well known that streptococcus induced hyperglycemic male rats. The reproductive changes include reduction of male organ and body weights. Okay, diminished fertility, decreased testosterone, and decreased gonadotropin levels, depletion of spermatogenesis, meaning they make less sperm, and testicular damage. So another usual consequence of hyperglycemia is the increased oxidative stress, which is extremely toxic to cells. Okay, so what happens is it's devastating to lipids, DNA, etc. Vitamin C or ascorbic acid is an important antioxidant substance in biological systems. It is a water-soluble micronutrient, well absorbed by the gastrointestinal tract, and required for multiple biological functions and biochemical reactions in humans and animals, and is an important element for the body. In addition, it is an essential nutrient for the biosynthesis of collagen and L-carnitine and norepinephrine. As humans are unable to synthesize vitamin C, they need this vitamin in their diet. Thus, prolonged deprivation of vitamin C generates defects in the post-translational modification of collagen, followed by illness and eventually death. Low levels of vitamin C are known to occur in several pathologies which cause increased oxidative stress, such as diabetes, cancer, cataracts, HIV, infection, smoking. In male reproductive system, vitamin C is known to protect spermatogenesis, and it plays a major role in semen integrity and fertility in both men and animals. Increases testosterone levels and prevents sperm agglutination. It is, which I assume is the sugar connection. Well, that would be glycation. I don't know. It is an important chain-breaking antioxidant, contributing up to 65% of the total antioxidant capacity of seminal plasma. 65% of the total antioxidant capacity of seminal plasma. Okay? This is just going over how it was done. Selected vitamins and quality of life in menopausal women. Vitamin B group. The role compounds from the group vitamin B cannot be overestimated in menopause. Folate and vitamins B2, B6, and B12 in their coenzymatic. Now, what you have to understand, these micronutrients, whether it's menopausal women or andropausic men, they're important because, as I stated, humans are the same species. We are not a different species. Women and men are the same species. So we have a similar diet. Okay, in a natural state, men and women would eat a species-specific diet. As I pointed out with chimpanzee diets and hunter-gatherer diets, and the role of supplementation after you go back to a relatively naturalistic diet, that's what you need to understand. If these micronutrients are working in women, they're going to be working in men. Okay? More often than not. B vitamins in general are cofactors for enzymes that are, because you have to remember, both men and women require all these micronutrients. I would recommend people read Bruce Ames's work on the triage theory of aging and disease. And check out Rhonda Patrick's Found My Fitness, and read Dr. Linus Pauling's books, and read Dr. Atkins' books, and read a bunch of other, that Cooper guy, the runner. Read the doctor that's a runner, Dr. Cooper. Read all these people's books on nutrition. Roy Walford. You're going to understand the importance of micronutrients to overall health. Dirk Pearson and Sandy Shaw. Deficiencies in any of these B vitamins can disturb the complex regulatory network maintaining one-carbon metabolism, resulting in a reduced methylation status within the relevant tissue. So it causes you to age. It reduces methylation, essentially. Okay, so the most common cause of a deficiency of B vitamin compounds in menopause is still an inadequate intake, as it is in younger folks. Among the reasons for insufficient supplementation are increased requirements during the menopause, malabsorption caused by intestinal malfunctions, an increasing number of diseases demanding the use of medicines interacting with vitamin B, and of course regarding addictions, alcohol abuse, etc. Alcohol abuse is no bueno. If you use alcohol, which I don't know why you would at this point, but if you're following my videos, you already know I support the 8 laws of health, and a big one of them is temperance, so don't use alcohol. Cardiovascular diseases and stroke, as well as cognitive declines resulting in dementia or Alzheimer's. Meta-analyses of early observational studies have revealed that lowering homocysteine levels by an acceptable vitamin B intake reduces the risk of stroke by 19 to 24%. Numerous studies have proven the correlation between homocysteine and low B vitamin intake, particularly folate and B12. Functional dementia consists of many morphological changes in the brain, reduced brain blood flow, neurological loss, neuronal loss, the presence of Lewy bodies, higher than age-appropriate brain atrophy, thinning of cortical gyri, as well as pathophysiological malfunctioning such as damaged connection between the neurons. The results of studies in groups with lower baseline folate status has shown correlations between folate in cognitive dysfunction and cognitive decline. Moreover, numerous studies then have associated low vitamin B12 concentration with cognitive dysfunction and cognitive decline in menopause and in older age. Similarly, decreased vitamin B6 levels was correlated with cognitive dysfunction and cognitive decline with a reduced risk of Alzheimer's disease. The role of vitamin B2 seems to be less imperative in cognitive malfunction in menopause, and the results of the studies are more controversial. Meta-analyses of observational studies have confirmed the associations of elevated homocysteine with bone mineral density. Okay, so what happens is elevated homocysteine, okay, so one meta-analysis concluded that homocysteine was an independent risk factor related to bone fracture. So high homocysteine, lower bone mass density. On the other hand, lower concentrations of folate and vitamin B12. As I said, you can literally test for a B12 or folate deficiency by looking at how high the homocysteine level is. That's how correlated these things are. So, vitamin C studied the influence of vitamin C. So Kim whatever, Korean women, yada yada yada. Vitamin C intake was positively associated with selected features of the bone health. Okay, femoral neck, blah 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 blah. It was done with a DEXA scan. Okay, the dietary intake of vitamin C was assessed using a semi-quantitative food frequency questionnaire, yada, yada, yada. Another group from South Korea studied the influence of vitamin C dietary intake on bone health. Okay, differently than in previous studies, population dietary assessment was evaluating using a 24-hour dietary recall, which is a little bit better. Menopausal women experience a rapid decline in left ventricle diastolic activity, which may mirror the heart failure occurring in the transitional period more frequently. Elevated markers of reactive oxygen species have been reported in the failing human myocardium. Attempted to determine whether oxidative stress may contribute to the decreased left ventricle diastolic function in estrogen deficient women, meaning they're deficient in estrogen. This is obviously some British crap because they spelled estrogen with an O on the beginning, estrogen, compared to premenopausal controls related in part to reduced nitric oxide bioavailability. In their experimental study, they compared features of mineral flow and brachial artery flow mediated. So you have to remember, if your blood's not flowing, shit ain't getting around your body, because your blood is a vehicle of nutrients and oxygen. Oxygen is a nutrient, but that's besides the point. People might not consider oxygen a nutrient, but it's a nutrient. Again, 8 laws of health, air. Okay, so 20 minutes after blah, 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 vitamin C in concentration, yada, yada, yada. Vitamin D, very few studies have investigated the association between vitamin D status and quality of life compared to the effects of 1 milligram of estradiol, yada, yada, yada. It confirmed the association between vitamin D status and health-related quality of life among the older population, women 50 years and over. The authors revealed the importance of vitamin D. Participants, blah, 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 blah. Vitamin D levels were significantly less likely to report problems with mobility. So if they had a higher intake of vitamin D, they had less issues with mobility, less issues with depression, less issues with anxiety. Vitamin E. Scottish menopausal women during the Aberdeen prospective osteoporosis study and found a positive association between serum A tocopherol and BMD bone mass density at the femoral neck. They did not find, however, any correlation between bone health status and the level of dietary vitamin E supplementation, which was assessed by accomplished food frequency questionnaires. Alpha tocopherol and gamma tocopherol, the two prominent isomers of vitamin E, were studied for correlations with bone turnover and artery stiffness in 278 menopausal women. The authors found a significant negative association, meaning more alpha tocopherol and pre-collagen type. Okay, so the more of this, the less issues you're having, essentially. Obviously, you don't want too much. So that's all for this. I'm sorry, moving forward, I meant. So, how much protein do you need to build muscle? While strength training is important for building muscle, so is consuming the right amount of protein. In fact, I would say that consuming the right amount of protein is even more important than strength training, because protein consumption is correlated with higher muscle density regardless of exercise. So protein is found in every cell and tissue in the body. This is why the low protein diets, like I did that experiment with the starch solution, it's a slow path to an early death. Don't do them. So consuming less protein than the body needs has been linked to decreased muscle mass. In contrast, increased protein intakes above the RDA may increase strength and lean muscle mass. So increased protein intakes above the recommended daily allowance may help increase strength and lean muscle mass, or lean body mass. Why is protein so important? Protein is made up of amino acids, building blocks for cells. There are 20 amino acids that combine to form proteins. While some can be synthesized in the human body, others cannot. The 9 amino acids that the body cannot make are called essential amino acids. These must be obtained through diet. Likewise, other body tissues, yada yada. If a person is not consuming adequate amounts of protein, their body tends to break down muscle to provide the body with amino acids. Now, what I recommend doing is especially if you're a vegan, supplementing with an essential amino acid compound. Okay? Now, I'm not a doctor. I'm not a nutritionist. This is not medical advice. But what I am saying is, if you are a vegan, I would supplement with an essential amino acid compound, and I would supplement with taurine and carnitine on top of that. Okay? So, lastly, the body uses amino acids for muscle protein synthesis. How much protein do you need? Okay, you need 1 gram. Okay, so most healthy adults, 19 years old, should get between 10 to 35% of their daily calories from protein. 1 gram of protein provides 4 calories. So, between 50 and 175 grams. Now, as they said, going above the RDA is better. Keep that in mind. So maybe a little higher than 175 grams. The current RDA is 0.8 grams per kilogram of body weight. A little bit over that is probably better. However, extending these recommendations to active individuals who are looking to build muscle may not be appropriate. When it comes to bodybuilding, or when it comes to building muscle mass, the ideal amount of daily protein a person should consume varies depending on several factors, including age, gender, activity level. Not really. Not really. That's a load of shit. Like, to be honest, yeah, it's 1 gram of protein per pound of body weight, whether you're a dude, a chick, or a kid. Period. If you want to build muscle, it is 1 gram of protein per pound of body weight, whether you're a dude, a chick, or a kid. And the reason why is because that's what's been shown to reverse sarcopenia. What is reversal of sarcopenia? It's building muscle. What do the studies say? While most studies agree that higher protein intakes are associated with improvements in lean body mass and strength, when combined with resistance training, the optimal amount of protein required to build muscle remains controversial. No, it doesn't. The rate of increase in lean body mass from higher protein intakes rapidly decreased after 1.3 grams per kilogram of body weight was exceeded, yada, yada, yada. Okay, yada, yada, yada. Now, they're going to talk about kidney issues that can develop, okay? What they found out is plant-based protein does not cause the kidney issues caused by animal-based protein. So what does that mean? If you're going to go high protein, go plant-based. Beans, peas, nuts, lentils, seeds, soy products, plant-based protein powders. Some nutritionists consider animal protein sources to be better than plant-based sources. That's not proven, though. This is because they contain all essential amino acids, so do plant sources. Some plant sources proteins are less bioavailable and harder to digest. They also have varying amino acid profiles. Yes, but if you're eating enough of them, you're getting it. You just have to eat more of the protein is the issue. But that's not an issue because you should be eating more of the plant protein because higher plant protein intakes have been associated with decreased all-cause mortality moving forward. So one of the biggest issues, if you've ever worked with kids in an athletic setting, one of the biggest issues is they eat shit. Okay? So eating protein doesn't equal big muscles. Instead, whatever. That's the truth, but come on. So work builds muscle. Strike a balance. While protein is important for muscle building, for building new muscles, eating the right amount of protein is key. Consuming more protein than your body needs may translate to excess calories, yada, yada, yada. How much protein is enough? Young athletes need slightly more protein than their peers who aren't athletes. They also need more protein because they're growing. Protein needs are based on age, sex, body weight, and stage of life. 10 to 30% of their daily calories should come from protein. As noted, you should probably be getting more like 30. Most athletes are able to meet their protein requirements and then some. Not if you're, because they might be reaching the 10% or whatever. They should be getting closer to 30 or higher. Best protein sources, of course, these are obviously meats, beans, whatever. We just went through that. Moving forward. So, what is the optimal protein intake? How much protein do you need per day? Tip on calculating, blah, 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 blah. Okay, so how much protein do you need? This is just going over the same crap. Caloric needs, yada, yada, yada. You can read this on your own. So this here is a nifty little tool. Oh, whoops. This here is a nifty little tool that allows you to calculate how much protein you need. So I am 40, I am 5'11", and I am 200 pounds. Oops. What happened here? I didn't want metric, US units. I am 200 pounds even. So I exercise 4 to 5 times a week. Calculate my protein requirements. So you have a couple choices here. Now I would go with the U.S. Center for Disease Control and Prevention, and I would fit more toward the high end of that. So the American Dietetic Association is 91 to 163 grams a day. That's not very much. The Center for Disease Control and Prevention says 66 to 230 grams per day. Now, of course, every day, this is what you have to remember, not every day are you going to be getting 230 grams of protein if you're my size. However, every day you should be striving to get a decent amount of protein. Now, the World Health Organization says that the safe lower limit, meaning the minimal amount of protein that I need to maintain my proper body functions every day, is 75 grams per day. So that's the minimal amount, according to the World Health Organization, that I need for my body to function properly. So I like using the Center for Disease Control. With the upper level there, you want to get closer to that level if you can help it. Okay? And moving forward, when we come back, I'm going to be talking a little bit about improvement of thymus function, the importance of fat intake and reproduction for hormone development, and the benefits of omega-3, plant-based omega-3s, and plant-based omega-6 fatty acids, and why you need them. And that'll be all for this video.